In this video, we're going to look at some properties for transforming power functions. So we're going to look at a couple familiar functions, x squared and x to the fifth, and how doing things to these functions will change the function. So thinking about x squared, that was just our regular parabola shape, and x to the fifth looked like this, and we're going to do some different transformations. So the first transformation we're going to do is we're going to add numbers outside. I always say if it's outside, it's easy. So adding outside, if you add 3 to x squared or to x to the fifth, it does the same thing. Outside is easy. Adding 3, it just makes sense. You move up 3. Same thing for subtracting outside. We are still outside that parent function. We have x squared with a minus 7 outside and x to the fifth with a minus 7 outside. Outside is easy. Subtracting 7, it makes sense. You go down 7. Now let's look at doing some stuff inside. Inside is the harder part. If you add inside the parent function, instead of just x squared, we're going to add inside, we're going to x plus 1 and then square, or x plus 1 and then raise to the fifth. So putting that plus 1 on the inside does the opposite of maybe what you think it would. Adding 1, do you think that moves it left or right? Well, if you think about a graph, to the right are more positive numbers, but since it's inside, it's counterintuitive. Adding 1 moves us to the left 1. Adding 1 on the outside moves it up 1. Outside, it just makes sense. When you're inside, it's kind of the opposite of what you'd think. Adding 1 moves us toward the negative numbers by 1, so we go left 1. Same thing with subtracting inside. Inside is harder. We're going to do x minus 6 all squared or x minus 6 all to the fifth. If we go inside that parent function and subtract, we're going to actually move toward the positive numbers. We're going to go right 6. Subtracting 6 inside moves us 6 units to the right. A negative outside, if you have a negative out front of the x squared, or a negative out front of the x to the fifth. We've seen this before. Having a negative coefficient flips it on the x-axis. Flips it on the x-axis from the top to bottom, or bottom to top. This would make it a negative x squared and a negative x to the fifth. It would flip it upside down on the x-axis. Versus the negative inside. If it's inside, it's going to flip or reflect on the y-axis. Left to right. So we would flip on the y-axis, which x squared is already symmetric about the y-axis, so it's not going to flip it there to look exactly the same. But x to the fifth flipping on the y-axis is going to flip it to the other side. So negative outside is x-axis, negative inside is y-axis. We've seen these factors out front before as well. When you have a number bigger than 1 out front, it makes it skinnier. It pulls it up so that it has a faster increasing slope. We call that vertical stretch. By a factor of 8. If we have a number between 0 and 1, it's going to compress it down. It's going to make it look flatter. It's going to vertically compress. Vertically compress by a factor of 1/3. So having a number bigger than 1 stretches it up. Having a number between 0 and 1 pushes it down, vertically compresses. So we're going to look at some multiple sequences of transformations. We'll look at horizontal shift, any stretch or compression, any reflection, and then also any vertical shift in the next videos.